Okay, let's finish up with a few questions, multiple choice, and see how we can calculate. So on the Did I Get This from page 169, suppose the mean hours slept per day among a sample of college students was 7.1 and a 95% confidence interval for the population mean was constructed. Which one of these could it be? Well, whenever we're calculating confidence interval, remember that 7.1 must be directly in the middle with the lower and upper limits split above and below. 7.1 is not the middle here, it's actually the lower limit. And 7.1 here is not the actual middle between 7 and 7.3. The middle here would be 7.15. Now, if you find the middle of 6.9 and 7.3, it is 7.1. Question 6, Did I Get This? Says, suppose that are based on a random sample, a 95% confidence interval among graduate students was found to be 6.5 to 6.9. What is the margin of error of this confidence interval? Well, remember, if we're talking about the confidence intervals, we have our statistic plus or minus whatever the margin of error is. So whatever's in the middle plus or minus the margin of error is what gives us the lower limit and the upper limit. So we have 6.5 up to 6.9. There's some value right in the middle that we would then take away a value and add a value to get our whatever our margin of error is. So in the middle of 6.5 and 6.9 is 6.7. Now 6.7 minus 6.5 and 6.7 plus something is going to, this is going to give us 6.9. This right here would be our margin of error, and this right here would be our margin of error. So you can think about it as the 6.7 minus 6.5 equals, or 6.9 minus 6.7 equals. That's going to give you your margin of error. And hopefully you notice that 0.2 is what you would add and take away. So the answer of that is C. All right, for each of the following situations, we want to determine whether it's valid to use a confidence interval to estimate the population mean. Remember, we're estimating when we don't know what the average of a population is. We want to talk about not testing a claim, so that's something to consider. In situation A, in order to estimate mu, the mean annual salary of high school teachers in a certain state, a statistics student selected a random sample of 150 teachers from the state, and the student found the mean and standard deviation of the teacher's salary. So I've got X bar here, I've got S here, I've got N here. I can determine whatever confidence level I want, 90 to 95%. I'm looking good. My sample size is bigger than 30. Our condition, it's random. We're good to go. This is valid. Situation B, a medical researcher wants to estimate the mean recovery time from open heart surgery for males between ages 50 and 60. The researcher followed a random sample, that's good, of 15 patients in this age group who underwent open heart surgery. The mean recovery time of 15 patients was 26. Well, I don't know anything about my standard deviation, and my sample size isn't bigger than 30. I need to actually look at the distribution. So right now we're having issues because this is invalid. Situation C says a statistics class wants to estimate the height of all male students at their college. They chose a sample of 35 male students playing basketball in the gym one afternoon. The student found the mean and the standard deviation and the heights of the heights in the sample. So we know N, it's bigger than 30, that's great. We know X bar, we know S, that's all great. But there's a problem in this question. They want to estimate the height of all male students at the college. They chose a sample of students playing basketball in the gym one afternoon, which is highly biased. A, they're playing basketball, which could say something about their height, and B, they're only sampling, this is a convenient sample, they're only sampling from just one situation in one afternoon, which is not going to be representative of the population. So this is invalid. And that concludes Module 25.